At this stage, I'm currently working on a 486DX2 motherboard build, and I'm waiting on some PCBs to do some testing or prototyping around a PSOC, a larger PSOC that I'm hoping to use in my design. And so I have some downtime as far as, hands-on working on PCB or any of that. And I probably don't want to progress with the actual motherboard PCB design until I get some validation done that this PSOC is going to be suitable for what I'm doing. So I have a little waiting, and I'm doing some reading, and there's a lot of work I can be doing, but I'm going to pick up a side project here while I have some of these gaps in the work that I'm doing. And I'm sure a lot of you will ask the question, why am I picking up a side project? And I think if you've been following me for a while, I'm kind of the person that likes to have things kind of always spinning. I typically have one or two projects, if not three projects running at a time to some extent. And right now, really my main focus has been this, Intel type of technology from the 286 to my 386 now to the 486 type of work. And it's really heads down into that. Now, during the day, I do something totally different. Electronics is just a hobby for me, so I can spend a little time some of the evenings working on stuff and trying to move those Intel projects forward, like this 486 that I'm working on right now. But then there's times where I'm waiting for things like a PCB to do some of this, prototyping on a PSOC. And after I get through that, I'll have some additional design work to do for the 486 build, and then I'll have to order up PCBs for that motherboard, and I'll be waiting again. And I also appreciate just being able to switch to something that's quite different and mix things up. Sometimes my brain gets a little fatigued with the same thing if I'm working on it too long. And so I like to kind of, maybe have an alternate thing I can go work on for a while and then come back to the main thing. On my x86 stuff, I was finding that as I would jump between, for example, 286 to 386 or 386 to 486 and back to 386 or back to the 286, so many of the concepts were very similar. And what I was doing in one project was really helping all of those projects I was working on. But it wasn't necessarily a big break from that technology. It was all really this Intel type of work. So I'm going to pick up a side project that is quite different. And what I really wanted to do was get back into something that is more of an 8-bit flavor. So not 32, not 16, but all the way back to something that's 8-bit. But at the same time, I wanted to do something more advanced than the 6502 or maybe the 65816 work that I had done in the past, all the way up through motherboards for those. But I thought it might be kind of neat to do something that's an 8-bit, and I'm going to actually go with an 8-bit microcontroller. And this is something I know pretty much nothing about. It's an HCS08 family. And so I think this goes back to the Motorola days, and maybe today it's NXP. But it's an 8-bit controller family or microcontroller family. And specifically, I am going to work with this one here. It's an MC9S08GT32. And so it's part of this, what they call a low-cost, high-performance 8-bit microcontroller unit. And it comes in a variety of packages and configurations, essentially. And that's what I'm showing in the upper right is the specific one that I'm going to be working with. So a little bit about this, this is just me reading up on the data sheet just to kind of get started. It looks like it's, 40 megahertz CPU that's on there, and it's, got a lot of support for interrupts and power saving modes and things like that. And there's on-chip flash memory. There's on-chip random access memory. There is an 8-channel 10-bit analog to digital converter. There's a couple of serial communication interface modules. There's SPI or serial peripheral interface type of support. Multiple clock source options. You can just kind of read through this list. There's a lot of stuff here. A keyboard interrupt module. And so this seems like kind of a pretty interesting little microprocessor. Now, if I understand it, this general family came out about 20 years ago, and maybe this specific chip I'm working with is slightly newer by a few years, if I understand it right. And I know some of you are probably quite familiar with this, whether it's the general family here or this specific chip that I'm going to be working with. But I think it's I'm going to do some rounding, it's about 20 years old as far as technology. And when I look at this package that I'm going to use, it's basically a 44-pin QFP. And here you can see to the left what that looks like as far as pin out. And so it's got 32K of flash built into it. It has 2K of RAM built into it. And in my case, 36 I/O pins that I can leverage. And so that's what I'm going to work with. And, if I look at what am I going to do with it, I don't know yet. Likely I'll try to find some type of peripheral to hook up and work with it. Maybe some type of video output, something really simple, maybe a little SPI screen or something like that. Maybe I can wire up a keyboard, a PS2 keyboard directly to it, and just get something really basic going. Now, some things with this that maybe I'll have to work through right away is, first of all, the package is not breadboard friendly. So if I do want to work with this on a breadboard, I'll have to either spin a quick PCB myself, or there's a bunch of them out there. I could just order one that goes from a QFP 44-pin to a DIP type of package, or I might just go straight to a simple little PCB that has this placed on it with some of the mandatory things I know I'm going to need to go with it, along with some headers or something like that I can be working with. Something else for this is my first 3.3 volt solution, but it should be interesting. And other challenges I think I'm going to have as I get into this is, how do I code for it? How do I assemble or compile, whatever's needed here? Then if I'm going to also look at creating a program for it, I've got to get that program burned onto it. And so I'm going to have to identify how I'm going to actually program this. There are some programmers out there. One of the programmers I see out there that would be usable for this is something called an Orange 5. I don't know anything about it, but it looks like it's used pretty heavily in the automotive industry, which probably also indicates that this chip, this microcontroller, is used in the auto industry, or has been in the past used in the auto industry. And I think it's also used for IoT and other types of solutions, but it seems like that programmer, the Orange 5, is really geared towards those in the auto service industry. But I think I can just build my own programmer. It looks like it's a single wire type of communication protocol to do the programming of the flash memory. So I'll probably just try to put together my own. So I'll have to have something that can let me take whatever I do take from source code into a binary, and then get that binary programmed onto this chip. And then find something that it can do that lets me test out some of its functionality. But I'm curious if any of you have used this chip. Is this a terrible chip to use? Is this an interesting chip to use? I definitely would be curious on any thoughts there. And I'm sure I could have picked, another dozen different types of microcontrollers. Well, there's probably hundreds to pick from. This is one I kind of just, I would say, relatively randomly chose. And honestly, the way I chose it was I was purchasing something else online, and I found someone that was selling a batch of these for $1 each. So I picked up a bunch of them, and that was with free shipping. So, I've got a dozen of these for a whopping $12 US, and I figure that should be worth the entertainment value as I get into this. And if I'm looking at what it can do, if it's got built-in flash memory, some built-in RAM, it can do some SPI type of things, I'll be really curious to see what can I do with that. Just the SPI alone is kind of intriguing to me. But if you've got experience with this chip and want to drop a note below, what's your experience been with this chip? Did you work with this 20 years ago or 10 years ago? And was it something automotive related or IoT? And any words of wisdom when you're looking at this chip?